Dynamic programming is a powerful optimization technique used in computer science and mathematics to solve problems by breaking them down into smaller subproblems and storing the solutions to these subproblems to avoid redundant calculations. It is particularly useful for solving problems with overlapping subproblems and optimal substructure. Dynamic programming is often applied to problems where you need to find the best solution from a set of possible solutions. It's commonly used in algorithm design and optimization problems. The basic steps of dynamic programming include: characterize the structure of an optimal solution. You break down the problem into smaller subproblems and determine how the optimal solution of the original problem relates to the optimal solutions of its subproblems. Define the recursive relationship. Express the solution to the original problem in terms of the solutions to its subproblems. This relationship is often represented as a recurrence relation or formula. Solve the problem iteratively. Start solving the problem from the smallest subproblems, typically using a bottom-up approach. You store the solutions to subproblems in a data structure, usually an array or a table, to avoid redundant computations. Build the final solution. Use the solutions to subproblems to build the solution to the original problem. Dynamic programming is used in a wide range of applications, such as optimizing algorithms for various problems like the Fibonacci sequence, shortest path problems, knapsack problems, and many more. It is especially valuable in cases where a naive recursive solution would lead to an exponential time complexity but can be dramatically improved to a polynomial or linear time complexity using dynamic programming.